Hi guys, welcome to the channel. So in the previous video we were discussing about the topic of torque, and we discussed two of the formulas for torque. One was giving the magnitude of torque and the other one was giving the direction as well. So now moving ahead, we are going to find out the different cases of the orientation of dipoles in which we are going to find the maximum and minimum values of torque. So first of all, if we want to find out the maximum value of torque, then in order for tau to be maximum, if you consider this formula, here P and E are going to be the constant values, okay, for a particular case, but angle is going to change. For tau max, sine theta needs to be maximum, right? And for sine theta are going to be plus minus 1. When we are going to find out the values of sine theta to be plus minus 1, when theta is equals to 90 or 270, or you can say pi by 2 or 3 pi by 2. So in the cases of dipole where angle theta is either pi by 2 or 3 pi by 2, in those cases we will be getting the maximum value of torque. So what will be those cases? Suppose this is electric field. This is the direction of electric field, and we want to make the angle of dipole. We want to make the angle between P and E equals to 90 degree or 270 degree. First of all, we'll take the case of 90 degree. This is the direction of E and we want to make P and E at 90 degree with each other. So direction of P should be like this, right? Then in that case, angle between this P and this E will be 90 degrees. So if we want the direction of P like this, then the dipole should be oriented like this, minus Q plus Q, like this, right? If electric field is like this, then we have to orient the dipole like this so that it is making an angle of pi by 2 between P and E. In this case, torque will be maximum. Or the other case could be, if electric field is like this and we want to make an angle of 3 pi by 2, then in that case, orientation of dipole should be like this, minus Q plus Q. So the direction of P will be like this and direction of E is like this, right? So overall, this is the direction of E and this is the direction of P. So overall angle will be 3 pi by 2. Pi by 2 plus pi by 2 plus pi by 2. 3 pi by 2. Here the angle was pi by 2. So if dipole is oriented like this or dipole is oriented like this, in these two cases maximum value of torque will be obtained and the magnitude will be P into E. This will be tau max, right? This is where we will find maximum value of torque. Now for tau minimum, in order for tau to be minimum, sine theta should be minimum, and minimum value of sine theta is equals to 0, that we all know. So in which cases sine theta will be 0? When theta is either 0 degree or 180 degree, right? Or you can say either theta is 0 or pi. Now we look for the orientation. Suppose this is the electric field and we want to make 0 angle between P and E. If this is E, then direction of P should also be like this, in this direction. So for that, dipole should be like this. So direction of P will be like this and angle between P and E will be 0 degrees. So overall torque will be 0. Now for second case, electric field is like this, and we want to make angle of 180 degree between P and E. So direction of P should be like this, right? So that angle between P and E is 180. So the orientation of dipole should be like this, plus Q and minus Q. So the angle between E and P will be 180 degrees. So in these cases tau will be minimum and the value will be 0. So these are the cases for torque in which we will find the maximum and minimum values of torque. Something which I wanted to discuss here in these two cases is that you will see that we are finding minimum value of torque to be 0. That is basically no torque is acting on it. This is what we have discussed while starting the topic of torque, that if the line of action becomes same, here you can see line of action is same, right? Here on plus Q charge, force will be acting in this direction. For minus Q, force will be acting in this direction. The line of action of these two forces have become same, and again their line of action has become same. I'm making just these two dipoles here again. Here minus Q and plus Q for this one, for this case, and here plus Q and minus Q for this case. Field is in this direction here, right? Electric field is in this direction, and here also electric field is in this direction. So basically here for plus Q charge, force is in this direction, for minus Q, force is in this direction. So basically their line of action has become same. This is what I have told here. And here for plus Q charge, force will be in the direction of electric field like this, and here force will be in the direction opposite to the electric field like this. So here also line of action has become same. So that is why no torque is acting on these two dipoles, right? Now what we can see next here is, in this case force are acting away from these dipoles and line of action has become same. So here there will be no case of spinning of dipole, and also the dipole will attain an equilibrium. And here also line of action has become same, so there will be no spinning motion and the dipole will be in equilibrium, translational, or you can say equilibrium, simply the equilibrium, it will not move. But here these two types of equilibriums will be a little bit different. So in this case of equilibrium, this type of equilibrium will be called as stable equilibrium. Forces are acting away from these dipoles, so this type of dipole is comparatively a stable equilibrium, is having stable equilibrium case. But in this case forces are acting towards the center of this dipole, right? So this is kind of an unstable equilibrium. Okay, so this is something which I wanted to discuss. So I hope this case is clear. So in the next video we will start with the topic of area and area vector, and after that we'll start with the topic of electric flux. So I hope this video was helpful for you. So far that's it for this video. Thank you so much for watching.